Hello and welcome to the Carbohydrate Chronicles, a podcast about glycoscience and glycoscientists. In this show, via a series of interviews, we explore the world of carbohydrate science and innovation from a personal point of view. Your host today is Tamás Rahaj, a member of CarboHydrate scientific team. Carbohydrate chemistry, the final frontier. These ubiquitous building blocks of life are still the most challenging biomolecules to manipulate due to their structural diversity and complexity. A realm where only the bravest chemists can go to deeply understand their biological importance, explore and embrace their therapeutic value. The use of carbohydrates as actives is an emerging field with a vast potential in several areas like cancer treatment, rare diseases, or infections. Our guest today is László Somsák, professor of organic chemistry at the University of Debrecen, expert in synthesis of glycomimetics and biologically active carbohydrates. Welcome, László. Thank you for accepting our invitation.
Thank you very much for your very kind invitation. So I'm happy to be here.
So are we, since you're the very first Hungarian guest in the podcast. By way of scientific introduction, László has been working at Debrecen University for exactly 40 years now, with a main research interest for designing novel synthetic routes to create carbohydrates, discover glycomimetics, glycopeptidomimetics, and lectin inhibitors. He is a board member of nearly all local and international carbohydrate organizations and serves in the editorial board of the prestigious journal Carbohydrate Research. He has almost 400 publications available on the topic. Let's see, you witnessed the rise of carbohydrate chemistry during your career, and you could follow different stages of the life cycle of glycoscience. How was it when you started this research field in the 70s, and how do you see the field now?
That's an interesting question because it was quite different. So, as you may know, I finished my university studies at the end of the 70s. We met relatively few carbohydrate chemistry and practically no carbohydrate biology. So at that time, there was not a very strong connection between chemistry and biology in general, and in particular in the carbohydrate field. So actually, I came to the carbohydrate field by chance. During my studies, I worked in the physical chemistry department where catalytic chemistry was pursued. And in my diploma thesis, I was dealing with the water-soluble analog of the famous Wilkinson complex, which is a rhodium phosphine complex and which was widely used as a catalyst in various reactions, especially in hydrogenation. Nevertheless, from the organic chemistry department, headed at that time by the famous professor Rezső Bognár, I got an offer to enter a fresh project in which they aimed at the synthesis of C-glycosyl compounds, mainly based on glycosyl cyanides. So I wanted to stay at the university because somehow I felt that this can be a good career path for me. And I undertook this and started to work on the carbohydrate field, actually with no previous experience and not much knowledge about this. So I have to learn everything from the very, very beginning, even the synthetic methods, which are sometimes rather strange with carbohydrates. This was the start. Actually, I had good teachers, the set professors, Rezső Bognár and István Farkas. And I also have to mention a technician, Zoltán Kupás, who was a fantastic expert in carbohydrate synthesis. And I learned a lot from him. And I must say that he was also one of my teachers in the laboratory. So, and after that, I continued, I did my PhD. Then, as in Hungary, it was usual, the so-called candidate's degree. after that, the Doctor of the Academy of the Hungarian Sciences degree, and I got the corresponding university ranks, assistant professor, associate professor, full professor, and I'm still here with a rather large research group. And I must say, at the end of my career, because in the coming weeks I will retire.
And do you have any plans? What will you do after you retire?
Actually, the university honored me by the Professor Emeritus titles, and I can stay, and also the research group will stay around us, around me. I hope so. We have a lot of plans with the younger colleagues, and I think that they can continue. I hope they will continue carbohydrate chemistry.
Of course they will. The listeners may not know, but Debrecen is currently the main hub of carbohydrate chemistry in Hungary. You mentioned that nowadays it's very different, carbohydrate chemistry or the glycoscience compared to when you started. So how is it now?
So as I can see, nowadays, there is a much stronger connection to biology, at least in my field. And this is, as I can say, mainly due to the development of glycobiology, the biology of carbohydrates, which is an extremely quickly developing field. And it must be in a kind of synergy with synthetic carbohydrate chemistry and also carbohydrate biochemistry to meet the expectations, to meet the requirements. That means to understand the roles of various sorts of carbohydrates in living organisms. Actually, our research field, which is based on synthetic carbohydrate chemistry, is directed towards biology for today, maybe 3 decades. And that was kind of recognition during my career that it is not enough to deal with the transformations of the carbohydrates, even if they can be considered new. It's better or it's even expected by, for example, sponsoring or financing organizations or authorities to show up some kind of utilization.
Let's take a step back from your career and glycoscience. So you're the first Hungarian on the show, apart from myself. So where were you born and how were your childhood years? Were they also linked to science already then?
Not at all. I was born in Miskolc. Miskolc is under Hungarian conditions. It is a big city. It was an industrial city with heavy industry for coal and iron and steel, and also in the surroundings, chemical industries. So actually, I was born there. I grew up there. And till the end of the secondary school, I lived there. So maybe during this time, I would like to mention some of my secondary school teachers, Béla Pirko, who taught us mathematics, wonderful fashion, Attila Hevesi, who taught us biology. So at the time, I really loved biology. And Zoltán Szepesi, who was our physics and chemistry teacher. And she wanted to convince me to be a physicist, but actually I insisted for chemistry.
And why was that, László? I mean, what made you fall in love with chemistry?
That was interesting. So already in the primary school, I liked chemistry. So we had the opportunity to carry out some experiments, and we also had possibilities to deal with chemistry, not only within the normal lessons, but outside. So I always walked from school to home on the main street of my native city, and there was a bookshop there. So a book, General Inorganic Chemistry, and after half a year, I dared to ask my parents to buy this book. To me, I don't know what was that, but started to read. So this was at the end of the primary school years. Of course, it was a very high level, something I did understand a lot of things, even in the secondary school. But after that, at the university, it turned out that the book was written one of our professors, Pál Szarvas, who was the professor of inorganic chemistry at the University of Debrecen, and I could listen to his lectures based on this book.
That was a long time present. You had to wait for several years to completely understand the book.
Yes, yes, indeed.
Do you still have it?
Yeah, of course, of course.
It's not that common. I mean, that researchers focus very specifically on the research field for a very long time, like 40 years, all your lifetime you have spent with carbohydrates. What is it in their chemistry that really caught you?
Yes, as you say, it is indeed unique and extremely versatile. So carbohydrates are rather complex molecules, which makes their chemistry quite complex and also difficult to pursue, because many reactions which look very simple do not work in the same way with carbohydrates. Basic textbook chemistry can be quite different on a carbohydrate molecule and can lead to very surprising results. During my career, I had several such experiences, which nevertheless led to rather interesting finding and even new carbohydrate synthetic methods.
So these surprises, do you like the carbohydrates because of the surprises or in spite of the surprises?
Maybe both.
Of course, as you mentioned, the glycoscience research is expanding very rapidly, and now it covers not only chemistry, but also biology and a lot of other life sciences. What are the research areas that you're most fond of within the glycoscience? What do you think hold the future of glycoscience?
I think and hope that glycoscience will be and is already becoming accepted by pharmaceutical companies. Nevertheless, this is not an easy story, because there are many obstacles for the use of carbohydrates as active drug ingredients. For example, the extreme water solubility or the sensitivity towards various conditions, mainly acidic conditions, which can be present in a living organism, and also enzymatic degradations occur rather easily. Nevertheless, and this brings us a little bit closer to one of my main research area, the design and synthesis of glycomimetics. So those problems, obstacles can be overcome by the use of glycomimetics, which are compounds which, as I like to formulate, resemble natural carbohydrates in their structure and or biological action. And these compounds can be much more chemically stable, can survive the living organism conditions. And I think that this can be a future direction of drug design, because it can step out of the heterocyclic landscape, which is even today characteristic. And not only because of this, but also the biological functions can be rather different and may open up unknown pathways towards new biological activities.
Yes, I completely agree that we are now facing the age of rapid expansion within the glycoscience, with day by day understanding better the biological role of carbohydrates, and that gives us, of course, a lot of potential and opportunities to design new compounds. And the development of glycomimetics is certainly one of these areas. Currently, your research focus more or less on biologically active carbohydrates, as you said. So it means that you're engaged both in the chemistry and in the biology of sugars. Which is more interesting for you?
This is done in collaborations. Fortunately, I have a rather broad network, both within the university and internationally, and have very nice colleagues who can indeed help and who can add other values to our research by investigating the biological effects, by studying protein or enzyme, small molecule, carbohydrate molecule interactions, by biophysical methods, and also protein crystallography. Another group is helping us by computational chemistry. So this is a really multinational collaborating work.
Yes, and such an interdisciplinary science and in the field where very broad knowledge is needed, collaborations are of course essential if we want to be successful. Speaking about your chemistry education, how do you see carbohydrate education now and the hopes for the next generations? Do you think that we can still maintain, I mean, in Hungary, world-class carbohydrate science in the future? Do we have good hopes for that?
I would like to hope for this. But I must say I am not very optimistic, because in the basic university education, carbohydrates are represented by a very small number of lessons actually, and also the background research is not really developing. But I must say that I have the feeling, and sometimes also the experience, that this is an international trend, which is a quite unfortunate development, because, as we spoke about just a couple of seconds ago, this can be a future directing field.
Maybe with the popularity of glycoscience, raising public awareness in this field, that may open up a few eyes that we need to revise how we face this kind of science and how we train the next generation.
That needs more attention, of course. Nevertheless, it needs also a lot of work. You need diligence, perseverance, and you must face a lot of failures during such a work. And I'm very sorry to say this, but during my several years teaching experience, students are looking for areas where, with the least possible work, they can reach something, and unfortunately carbohydrate chemistry doesn't belong to those fields.
Is not a low-hanging fruit, right?
Yeah.
No, but I still hope that, and then I still believe that, of course, there are people, usually the bright ones, that aim for doing something big and can dream big and are not afraid to accept challenges. How about the private sector? Were you never tempted to go into the private sector?
Shortly, no.
Okay, fair enough. What do you enjoy more? I mean, you have clearly a very intensive research activity, as well as do you participate in the education? Which brings more joy to you?
I can't choose. Actually, teaching at the university was also a very joyful activity for me. And this also gives the opportunity to meet students whom we can convince to come to our lab and to work with this painful chemistry of carbohydrates. I also enjoyed elaborating new subjects. So, for example, I am very proud of a reaction mechanism in organic chemistry course, using or utilizing frontier orbital theory, stereoelectronic effects, and least motion principles, which gave the possibility to handle the whole organic chemistry, starting from the basic ionic reactions and ending up with pericyclic and radical reactions.
Let me ask you, what do you do when you're not in the lab? Do you have any hobbies?
You see, the stereotype answer is that my work is my hobby. Yes, indeed. So if you wake up in the morning or in the dawn, sometimes very good ideas may occur. I was also active in non-chemistry fields. So, for example, with the family, we frequently went for skiing during summer, for rowing. Unfortunately, due to some health problem, this had to be interrupted. Otherwise, I very much like reading many things, fine literature, and also popular science in other fields. And one more thing. So I love listening classical music.
So let's talk about the science that you're doing. What are the research areas that you currently focus on in your team?
We are dealing with the design and synthesis of glycomimetics. So this is biology-driven or biology-oriented part of the work. On the other hand, we are also developing carbohydrate synthetic methodology, which comes more or less hand in hand and which is synergistic. For example, elaborating new kinds of inhibitors requires new types of compounds which are generally unknown, and there are no synthetic methods. So that means that reaching, let me say, biological or biologically oriented aim needs hard chemical work as well.
How should we picture the relationship? Do you have a therapeutic area that you focus on and try to design glycomimetics and then use different synthetic strategies, or it's the other way around? You evaluate new strategies that results in new compounds, which you then test in different biological.
Yes, again, I can't say yes or no. Because sometimes the biology drives us, and at the next time the chemistry. So this is quite interesting. So let me speak about a recent finding. So we were studying the thiolene addition reactions of certain so-called 1C acceptor substituted glycal compounds. So we found a very interesting course of the reaction. Glycals without such electron-accepting substituents reacted with thiols unselectively. That means that the reactions were not stereoselective. They produced different stereoisomers. In our cases, the substrates produced stereoselectively only one compound with a certain stereochemical outcome. And this was very interesting. This was a new type of thiodisaccharide, which we indeed didn't know what to do. And we did not know what kind of biological activity could be expected. And it came by fortune that we met with a Swedish chemist, Ulf Nilsson, who could test these compounds as galactin antagonists. Galactins are very well known carbohydrate recognizing lectins, and they are responsible for a very wide range of biological phenomena. For example, cancer metastasis and fibrosis and many other things. And it turned out that they are better inhibitors, better antagonists of certain types of galactins than all of those compounds which were studied before.
As you describe the work, it indeed sounds like a great discovery. So I can assure you, it sounds very nice. And I know that Ulf Nilsson also had already outlicensed some of his compounds to companies who are developing galactin inhibitors. So this is certainly a varied life cycle for new compounds. If you look back at your whole career, are there a specific project or an accomplishment that you're particularly proud of?
Yes, I'm proud of the elaboration of an aprotic glycal synthesis. This was at the end of the 80s, beginning of 90s, and till the time glycals were synthesized by the classical Fischer-Zach method. And this produced the corresponding glycal, sometimes in good, sometimes in horribly low yield. We came to this new synthetic method by chance. At the beginning of my career, I discovered a kind of radical bromination of monosaccharide derivatives, C-glycosyl heterocycles and glycosyl cyanides. And after that, I started a systematic investigation. And among them, I wanted to see how they can be debrominated. I speculated. Derek Barton said that speculations are free. If they are successful, you will be famous. If they are unsuccessful, then it can be kept as a secret. So
No one will know.
No one will know. I tried to reduce this compound by zinc, and I thought that let's try it in an aprotic solvent. So I tried it in benzene and added hydrogen donor molecule, triethylamine. I got an unsaturated derivative, and it turned out that they were these cyanoglycans. So this was the first observation, and then we moved on to the normal acetobromo sugars and wanted to try these conditions for the synthesis of the simple glycans, and it turned out that it worked. And as far as I know, this was also introduced in some companies for the large-scale production of glycans. So we were not clever enough to file a patent about this, so it was freely available, the method. Nevertheless, I could visit such a small company, for example, who applied our methods in a cubic meter volume. So since then, this method has become part of carbohydrate textbooks and carbohydrate monographs. So I think that this was indeed a good achievement.
Certainly, for a chemist, I mean, the method that you invented reached its final purpose, and it became practice. So that's nothing more that we can dream about. Last question, not related to your science. Would you have any advice for young scientists who are just starting their careers?
So one has to be curious first, then insisting or perseverant and diligence. So without that, I think no real new results can be reached.
I hope you enjoyed the most recent episode of Carbohydrate Chronicles today, delivered to you by CarboHydrate. We talked with László Somsák, professor of organic chemistry at University of Debrecen, expert in the synthesis of biologically active carbohydrates. Capturing László's views, we should be humble, curious, and persistent, and grateful for advices and learning opportunities, no matter where they come from. There is also maybe an advice for teachers and parents that we can draw, because many of the guests had said that their fascination for chemistry runs from childhood experiments. So you should experiment chemistry with your kids, as apparently these memories stick with them more than textbook knowledge, and they can be a very strong foundation for lifelong addiction towards chemistry. Thank you very much for being here with us, László. This was a fascinating discussion, and
it was my pleasure too. Thank you very much.
Thank you all for listening to this interview. Next week, I'm talking with Parastu Azadi, Technical Director at the Complex Carbohydrate Research Center of University of Georgia, who is a world-known expert for structural characterization of different types of oligosaccharides, glycoproteins, polysaccharides, and glycolipids. Your host was Tamás Haida from CarboHydrate. I hope you'll join me in our next episode too. See you in one. Goodbye.